All right, today I really want to look closely at logarithms and their exponentials and that relationship. So let's see what happens when I take f of g of x. Oops. Remember, f of g of x means I'm going to take log of g of x. I'm going to substitute in g of x for x. Now remember what happens here. This is log base 10, right? It's telling me what the exponent of 10 is. It gives me x back. Even if I did the opposite way, if I went and took g of f of x, so I have 10 to the log x. Well, we already have played with this enough to know that we just get x back. Now, what does this mean to us mathematicians? What does it mean? It means that I have inverses. These are inverses of each other. Now, how does that affect me? Well, that means that it's not just base 10. I wonder if a lot of them have inverses. Like, what do you think the inverse of log base b would be? Now, this was base 10, because this is base 10. Well, we can have other bases for exponents, so we can have other bases for logarithms. Neat, huh? And they rewrite just as pretty as that too. So let's do a equals x. They always rewrite the base to the exponent equals the argument. Always like that. So if I had, let's do a few, log base 2 of 8 equals 3. Is that true? Does 2 cubed give me 8? Well, it does. What if I'd had log base a of 4 equals 5? Well, that really means a to the 5th equals 4. What about, let's go the other way. What if I knew 3 to some power gives me 7? Well, if I rewrote it as a log, the base of the logarithm is the same. The exponent is the answer. So let's look at a few other examples, and we're going to find the values of these. What if I wanted to find log base 2 of 16? Now, we're trying to figure out what that equals. It's a big question mark right now. So what that really means is 2 to what power gives me 16? Well, that's 4. What about log base 3 of 1 over 27? 3 to what power gives me 1 over 27? That's negative 3. Your answer is always the exponent in question. Log base 12 of 1. 0. Log base 5 of 5 to the 4th. 5 to what power gives me 5 to the 4th? Hey, that kind of meets that inverse thing that worked with logarithms. They undo each other, but they have to have matching bases to undo each other. So anytime this base matches that one, they're going to undo each other. It doesn't matter what order they're in either. They're going to undo each other. So that's all really good to know. Now, our properties of logarithms still work the same way as well. When we are condensing logarithms, now one thing important is that they all have to be the same base. But when we're condensing, we want to look for exponents first. So this is condensing. So I want to pull in any exponents first. So that 4 is going to go up there. So I've got log base 4 of 20 plus log base 4 of x to the 4th minus log base 4 of y. So these are going to multiply. Subtraction, when I combine, it becomes division. The rules don't change. Even on expanding, they don't change. The only thing we're going to have to pay attention to is that the bases here all have to match.